Okay, so we have our first question here. It says, assume Zesco is the sole provider of electricity in Zambia. To meet the monthly demand for electricity in the country, which is given by the inverse demand function, P equals 1000 minus zero point 0.5 Q. The company has set up two electric generating facilities. Q1 are kilowatts produced at Kariba Dam and Q2 are kilowatts produced at Victoria Falls. So Q total quantity is Q1 plus Q2. Okay. The cost of producing electricity at each facility are given by the cost function here, 10,050 plus 5Q squared, Q1 squared, and second cost function Q2 equals 10,050 plus 5Q2 squared respectively. So we start with the question. Determine the profit maximizing amounts of electricity to produce at the facility. So colleagues, one thing we need to remember is the point of profit maximization is where marginal cost equals marginal revenue. This is the point of profit maximization. Okay. So in this question, first, we need to get our marginal revenue, our marginal costs. Then we can equate them. All right. So this is the first thing that we need to do. First thing, we need to set up our total revenue function. Okay. So you say total revenue TR equals price times quantity. Okay. Now here, notice we've got two quantities for two different places. All right. And two costs for two different places. So this method I'm showing you is the shortcut method. Okay. This method will save you a lot of time when you're dealing with such questions. Okay. Yes. So initially do everything like there's just one facility. Okay. Assume there's one facility for the first part. Okay. So here our price is this 1000 minus, let's see what's the price, 0.5 Q. Okay. Multiplied by our quantity Q. Okay. So this is the total revenue for both Kariba and which other facility was this? Kariba Dam and Victoria Falls. Okay. So we're going to say Q times 1000, get 1000 Q. Q times negative 0.5, get 0.5 Q squared. Okay. Yes. So remember, marginal revenue is the derivative of the total revenue. So after that, you get your marginal revenue. Colleagues, let's derive this function from what we learned yesterday. If we derive this function, what do we get? Anybody to give me the answer before I give the final answer? If we derive this, what do we get? Because these are the questions you'll be dealing with. So differentiation, you have to be very conversant with it. Yes, correct. 1000 minus q. Okay, remember differentiation, you multiply the exponent with the coefficient, the number in front of the letter. So 1 times 1000, you get 1000. You subtract a 1 from the exponent. So here you have 1000 q to the power 0. Now anything to the power 0 is 1, so you don't need to write q to the power 0. Then here 0 0.5, multiply exponent 2 times 0 0.5, that is 1. You subtract a 1 from the exponent, you remain with 1 q to the power 1. Are we all okay with that? Okay, now we go to our cost functions. Okay, our total cost functions. Our first one here we have CQ1 equals 10,050 plus 5Q1 squared. So to get our marginal cost, we need to derive. So colleagues, if we derive this one, what do we get? If we derive this, 10Q, yes, 10Q1. Okay. Any number without a letter, it disappears. So this 10,050 goes. So here we have 10Q1. And it will be the same for the second one, the second cost function. They're identical cost functions here. Because 10,050 plus 5Q2 squared. So get 10Q2. Yes. So here, first things first, as I said, the point of profit maximization is where marginal revenue equals marginal cost. So here we've got two marginal costs, MC1 and MC2. Okay. So since we've got two marginal costs, first thing what we need to do is we need to make the variables. We have to find the value of either Q1 or Q2 so that we can do some substitutions here. Okay. So if we equate first the marginal costs, 10Q1 equals 10Q2. If we get rid of these 10s here, it's the same as Q1 equals Q2. Okay, because we want to make either Q in the form of Q1 or Q in the form of Q2 so that we can first find the value of Q. Okay, so when we equate the marginal costs, okay, we see that Q1 equals Q2. And if you remember in the question here, it told us that Q equals Q1 plus Q2. Okay, they tell us Q equals Q1 plus Q2. Okay, so what we can do using this identity here where Q1 equals Q2, we can substitute it back into this equation here. Okay, so here if we want, we can say this Q2 here, since Q1 equals Q2, so we can substitute this Q2 here with Q1 because Q1 equals Q2. So it's the same as saying Q equals Q1 plus this Q2. I've substituted it with Q1 here. Q1. So Q equals 2Q1. Okay, colleagues, the reason why I'm doing this is so that we're able to find the value of Q. We've got two different cost functions, all right? So we want to first find the value of one Q so that we can find the value of the other Q. Now, in this case, since the cost functions are identical, it means also the marginal costs will be identical, all right? Yes, so that's why we said here 10Q1 equals 10Q2. If we get rid of the tens, it's like the same as saying Q1 equals 2Q2. And then we get our original function, which was given in the question here, and substitute so that we can have a simple expression like this. Any questions, colleagues, before I move further? Okay, since we found that Q equals 2Q1, we can now get back to this expression here. Okay, so we go back, we say, so we can now work with one of the marginal cost function. So we can say marginal revenue, MR equals MC1. Okay. Whatever we find for MC1, we'll apply to MC2. So our marginal revenue, we said it was 1,000 minus Q equals, our marginal cost is 10Q1. Okay, 10Q1. Then, since here we found that Q equals 2Q1, that's what don't call it. Hello? Mm-hmm. Yes, okay, sorry about that, colleagues. Yes, so here Q equals 2Q1, so we substitute it back in here. This becomes 1,000. Hello? 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 Yes, so 1,000 minus, so Q will replace it with 2Q1 here, equals 10Q1. Okay, so now at least we've got Q is now in the form of Q1, so we can easily solve. Okay, that was the main problem here in this question. You want to put Q so that it's in this, it's either Q1 on both sides or either Q2 on both sides, so that you can first find at least one Q1, then you can find the other. Okay, so here 1,000 minus 2Q1 equals 10Q1. So group like terms together. 1000 equals 10q1 plus 2q1. 10q1 plus 2q1, that is 12q1. We have 1000 here. So if we divide both sides by 12, 1000 divided by 12, let's get our calculators. What do we get? 1000 divided by 12. Yes, 83.33. Q1 equals 83.33. Okay. So we want to find now the value of Q2. Okay. Now if you remember here, we've been told Q1 equals Q2. So Q2 is also 83.33. Okay. Q1 also equals Q2, which is 83.33. So we can also see this Q2. So colleagues, you only do this if they're identical. If they're not identical, then you have to use the long root. Okay. Here goes with identical cost functions. So Q2 also equals 83.33. All right. Then if you want to find the total value of Q, remember Q equals 2Q1 or Q equals Q1 plus Q2. Remember these two. You can use any of these. So if we use this one, Q equals Q1 plus Q2, we just say 83.3 plus 83.3. What do we get? Uh-huh. That is our total Q. Any questions? So a small recap. First thing, get your total revenue function. Okay. This is the overall total revenue. That's why you're using Q here. Then get your marginal revenue functions. Okay. You get your marginal revenue function. Then after that, get your marginal cost functions. Okay, because you have two marginal cost functions. All right. Then once you get your marginal cost functions, equate them so that you can have an identity for Q. Okay, so that you can solve one marginal cost and then apply it to the other one. Okay, as you saw here, from our marginal cost functions, we saw that Q1 equals Q2, and we applied it to the condition that was given in the question. All right, then once you have done that, you can now equate Q into either Q1 or Q2 so that you can easily solve your marginal cost function. Then, okay, we go to part 2. What is the optimal price? So here, P equals 1000 minus 0.5Q. All right, so the optimal price, P equals 1000 minus 0.5 Q. So here we're going to say 1000 minus 0.5, and here we get 166.66. So half of 166.66, that's 83.3. 1000 minus 83.3, what do we get? 91. I've confirmed 916.67. The utility company's profits. So profit, remember, profit is total revenue, TR, minus total cost. So we need to combine the cost functions, okay? We combine the cost functions. This plus this one, okay? Then we get our total cost. Or if you want, you don't need to even actually combine them. Just substitute Q1 in the first cost function and Q2 in the second cost function. So okay, so let's do that. C1 equals 10,050 plus 5. Q1 is 83.3, so 83.3 squared. So 83.3 squared is 166.66. Then 166.66 times 5, 833.3. So get 10,050 plus 833.33. I mean, 166.66. So 166.66 plus 10,050. You get 10,216.66. 10,216.66. Any questions? Then, so also QC2 is going to be the same as this one also. So if we need to get our total cost, we just multiply this by 2. Because see, remember, the cost functions are also identical. Okay. So this times 2 to get our total cost. Our total cost is going to be, where did I take that down? Total cost is, just get that number back. I don't know where it put it here. Hello? Yes. Okay. What, I'm just trying to find that value we found here. Yes, 10,266, 10,216.66 times 2. So our total cost, when we multiply this by 2, since they are identical cost functions, so when we multiply this by 2, our total cost is going to be 20,433.32. That is the total cost. Then total revenue, where's our revenue function? 1000 Q minus 0.5 Q squared. Remember our total revenue function, 1000 Q minus 0.5 Q squared. So we already have the value of Q. So you say 1000 times 166.66 minus 0.5 times 166.66. Which sign? Minus. Minus, madam. Maybe it was a slip of the tongue. Minus. Minus. 1000 Q minus 0.5 Q squared. So 1000 times 166.66, that's 166,660 minus 166.6 squared divide multiply by 0.5, we get 13,877. 887. 13,887.77. So 166,660 minus 13,887.77, we get 152,772.23. Okay, that is our total revenue, 152,772.23. That's our total revenue. So to get our profit, it's this total revenue, 152,772.3, minus our total cost, 20,433, 433.32. So 152,772.23 minus 20,433.32. And our profit is going to be 132,338.91. That is our profit. Total revenue minus total cost.